Welcome to another DraftScience presentation, such, something like that. Anyway, the whatever Nor guy has again keeps defending his version of this animation, um, and he just keeps ignoring the points being made, in my opinion. And maybe he's just misunderstanding over and over again. So we'll see if we can clear anything up here by being more specific or whatever it takes, but really is getting tedious as hell. Alright, so anyway, quotes me. So this is point number one, which is the photons move in straight lines. They don't go forward in time. And certainly at the time of Michelson-Morley, there was no concept of relativity or this whole frame warping. The headlight effect wasn't talked about, all that kind of stuff. Photons were thought to move straight from the point they were emitted, blah, blah, blah. So no reason for Michelson-Morley in speculating about movements at, say, half the speed of light or very fast movements of their machine, that there would be any expectation that photons would move forward in time, have two momentums. Alright, and he says, in this case we have to think about how the real experiment was done. They rotated the device so that the role of the two arms was switched. And again, my point is if the two arms have exactly the same time, distance, then it doesn't matter where you rotate it. It's always going to be the same. Because it's always, no matter whether, there's no difference in the two lengths. It looks like this one's not changing as much, but it does in fact change just as much as this one. That's the truth I'm arguing. So rotating wouldn't change that at all. It would just change the percentage, how much distance, new distance is created. Alright, this means that if the photons miss the arm in one scenario, I don't know what that would even mean. They missed the mirror, not the arm. Or if you had to compensate for what you're talking about, this would have been noticed when you rotate the device. Well, again, these showing the theoretical potential of the device is being shown by exaggerating speeds. If you do it at common speeds, the differences are so tiny that you couldn't notice them. And certainly you wouldn't notice them in any animation or something else. So it's by the very idea that you use exaggerated speeds that you're able to see the defect in the experiment. Rotate the device because then the vertical arm would become the horizontal arm. And it doesn't really matter horizontal or vertical or half vertical or wherever you put it, it's always going to be equal. Because it's always equal. In the two extreme positions, it's equal. This way and this way ends up being equal. So this way and this way will be equal. This doesn't matter where you turn it, it's always going to be equal. Alright, and you're just not dealing with the point, which is at the time Michelson-Morley conceived this experiment, there was no expectation that photons go this way for free, that you shoot lasers this way at the speed of light, and at the same time the laser light moves this way. There was no, or this way. No expectation, no rational expectation that that takes place, that I can throw light by moving my flashlight. I can throw the light in a direction. That would have been thought of as ludicrous. There are two various scenarios you can come up with, but the claim is that you would have noticed them if you rotate the device. Again, there would be no way to notice them at the speed of 10,000 miles an hour or 20,000 miles an hour. You wouldn't notice them in any practical sense by doing anything other than measuring what you're getting in terms of your interference or some other nonsense, but you won't be able to measure the distance difference. It's such a slight difference. You can't measure it with a ruler. you have to use an interferometer. Jeez. But again, just totally ignores the point. This is about the headlighting effect. This is about you claiming that you can have photons that go this way for free. You don't have to account for it as a time delay. They get to go this way for free, and the only part you count is going this way. And you can't do that. Alright, so then my second point, which relates to the hypotenuse of the triangle being a longer distance, and that's the distance you have to travel. And he says, yes, it reflects out at exactly the same angle. Well, so now we're just doing the, ends up being a triangle, a 45-degree angle. Well, 90 actually. I don't know where you got the idea that it goes back in a vertical line. I'm talking about the fact that you're where the mirror is centered is the problem. Are you centering it on the total distance, or are you centering it based on the fact that it's moving the same speed as the mirror? I mean the beam splitter. The mirror is moving with the beam splitter. So it has to be the halfway point of the beam splitter. And the point I have made before is that if you do that line at the speed of light, you can't get to the mirror in time. That was one of the angle points. And the second angle point would be, that wasn't even mentioned, was the fact that now the mirror is moving, and when the light reflects off of it, if it headlight affected when it was emitted, if you have a headlight effect, why wouldn't you have a headlight effect on this mirror, which would cause even more of an angle? You wouldn't have angle in, angle out if there's a headlight effect from the moving mirror. I'm just saying you can't have it both ways. You can't say the headlight effect happens when the emitter's moving, but the headlight effect doesn't happen when the mirror's moving. Alright. I don't know where you got the idea that it goes back in a vertical line. No one is saying it goes back in a vertical line. Well, I'm saying the way you've calculated your whatever it is, animation, you're essentially not accounting for any movement horizontally. Alright. So when the diagonal photon gets to the mirror, it had traveled 66 pixels to the right and 160 pixels up. So this is a huge mistake. You can't measure this in pixels. So I'll do the drawing now. Yeah, because it's just a fundamental mistake. You can't think of it in those terms. You have to do explicit measurements. You can't cheat, and pixelating cheats. So pixels are like this. Pixels. So let's add 4, and I was doing 5 this way. Right? Here's the paper. Alright. So you just fill it all in, right? Pixels, pixels. They're all equally distant from each other. Pixels, 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 pixels. Pixel, pixel, pixel. Now, the problem with pixels is when you try to do a diagonal, it doesn't work with 5 by 4. You end up with some kind of But the point is, if you add up, like say if you just average those, let's say this one was here and this one was here, it's still 5. See? 1, 2, 3, 4, 5. It doesn't accurately reflect that this line is not the same length as this line. See, 5 here, 5 here. So you can't use pixels. You have to do real measurements. You have to say this is going to be 1 centimeter, let's say, and so that will represent 5, and then 4 would be 3/4 of, you come up with numbers. Like I said, doing half the speed of light makes this easy, because then you just have 10 and 5. So it makes it really simple. You can simplify it into whole numbers. But regardless, you have to do actual measurements of distance. You can't pixelate it. You have to actually measure this line and say that this is 1 centimeter, this is 1 centimeter and 0.75 extra. And that's the whole point here. So again, you're not doing accurate, professional model making. You're breaking the rules. So continuing. Alright, when the diagonal photon gets to the mirror, it had traveled 66 pixels to the right and 150 pixels up. When the diagonal photon gets back to the splitter, it had to travel 66 pixels to the right and 150 pixels down. Alright, so anyway, a perfectly symmetric reflection. Yes, but the point is this longer distance, when the mirror's here, means that in this time that it takes to do this line, that's only going to get you here. It's not going to get you to the mirror, and that's the problem. Alright, so then the rest of my point is, and that the distance required you to do some math. Did you do this simple Pythagorean math? Did you take the square of this? Okay, and so he says, yes, I did the math. No, you didn't. So I want to see it. I want to see what you did. How did you construct your GIF? I'm just saying, if this is your creation, you should be able to explain, well, yeah, for each frame, I did it this way. But it seems the fact that you're using the word pixel means you can't do diagonal lines with pixels. It won't work. Alright, so he says the stationary legs are 150 pixels. The diagonal distance is square. So it's 66 and 150. So let's understand that this is not, I don't know why he chose these numbers, but they're clearly not really great. So 150 represents the speed of light. The 66 represents the speed that the instrument's moving. So it's moving something less than 1/3, no, something more than 1/3. So like I said, 40% maybe, but I don't know, somebody's got to do that math. But it's like nowhere near anything fun to work with in terms of numbers. So I don't know why he chose these numbers, but they're clearly not very friendly to make this more obvious. Alright, so anyway, so here we're continuing. However, as I claimed in the previous post, the speeds of all four balls are the same. Well, the speeds can't be the same. You can't change the distance in your model, right? You can't warp distance to reflect changes. So you have to change the speed of the object to reflect a diagonal line. There's no other way to do it. You have to slow the ball down, okay, because you can't physically change the distance in the pixel world. Okay, so you know, you have to cheat on one of the variables. Either you cheat the speed or you cheat the distance in your model, but you have to warp one of them to the circumstance. But anyway, however, as I claimed in the previous click, the speed of all four balls are the same. All of them move at 5 pixels per frame. So again, 5 pixels. You can't use pixels. Pixels are not a measurement of real distance, especially a diagonal of pixels. Note that the 163.88 divided by 150 is 1 point whatever, so the diagonal distance is 9.25% longer. So this is the joke part here, the funny part. It is longer, and the diagonal photon does take more time, but not by as much as you claim. So he doesn't think 10% is a lot. So let's go back to the animation and just think about the distance this ball is traveling. The one going, alright, I have to do this with in here for the stupid mouse to be right. So think of the distance traveled here. So the ball leaves going this way. So this is the one we're looking at. Okay, this total distance that the little red ball travels. And look where it stops. Now, doesn't that look like just about 10% of the total distance? So if let's just count, let's say. So let's count when it leaves. When it leaves, 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, look at that. Yeah, one more little bit of distance and it would have hit. So that 10% is huge. So you make this little ball move 10% slower, right? This one going up. You make it go 10% slower, and these two balls hit at the same time. 10% is huge in this circumstance. So I don't know how many times I have to go over it. So I don't think you've addressed either point. The first point being that Michelson-Morley had no understanding of any headlight effect. Clearly, because Einstein hadn't invented it. And so why do we expect photons to go this diagonal path? Why do they move with the experiment in this direction? How do they know to do that all by themselves? This little photon can know to go two directions. The speed of light this way, and magically 1/3 the speed of light in the other direction. It can't. And clearly, if you obey the rules and recognize that this photon is traveling a diagonal line, a triangle, to get there, that those lines are longer distance, and it takes more time to travel longer distances. Alright, so I just don't know. I shouldn't have to go over this any more times. So, so he says 2 comments there. So the other guy, I just want to make sure he's the one who wants to do the bet. My comment isn't showing up, but I don't think it's because I'm blocked. I hope you see it. Anyway, if you are still thinking about the details, or if you aren't interested, please tell me. I'll stop bothering you in that case. Well, I'm just saying we haven't really established, now that we know this thing was done with pixels, we know reality isn't pixels. So we know reality, like on a checkerboard, the spaces can be the same number of spaces on the diagonal, right? The diagonal line can be exactly the same number of spaces. But you know, if you move diagonally, you'll cover more space across the board. So you do know it's longer distance. Same number of squares, but a longer distance. Well, reality doesn't work that way. You don't get any free travel time going a diagonal. You can't shoot photons. You can't find the matrix of the universe, the checkerboard of the universe, and say, I'm going to shoot the light on the diagonal and go a longer distance for free. You can't do it, because the universe isn't pixelated. Alright, so that's probably enough. Keep it to the one subject. So, yeah, like I said, he apparently just will not. I thought he had sort of conceded the point when he made his little video graphic, and he actually drew the line as an A shape, that he was actually getting it, that that's the actual travel path, and that you have to account for that line being a lot longer than the straight up and down line. And he apparently just doesn't wish to do that. So, okay, enough of the video, I guess. Yeah, I have electricity again, so I should be getting back to normal, but I'm, I'm just kind of done in, a bit tired, and blah 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 blah. So maybe a comment video later, but we'll see how it goes. I don't think there was any, reasonable comments. There was something else I wanted to comment on, though. Yeah, maybe I'll do a Professor Lewin video. I did comment on a video he made, and it was a very unsatisfactory exchange of comments. So I figured I would go over it as an example of how you just can't talk physics with people, because they just won't play by the same ground rules. They can say something and you say, well, that doesn't make any sense, and they just say, well, then you look at my equation and you say, well, how's your equation prove it's right? Where's your experimental evidence? What? I don't need that. It's just, I don't know. Well, whatever. This is so bad. So anyway, till next time, such. I think that's all. I don't know. There was this weird. I must get rid of his comment because it was just so stupid. So some weird person, lights out in Mendham. His first original comment before he edited it was something like, "I have seen the videos. You're done," or something. So, and now it's just a winky face. I don't even know what that means. But whatever. Go away, silly person. These people who think they can threaten me with something. You know, go ahead, make my day, okay? I mean, really, you know. Yeah. You feel lucky? Yeah, I'll do a Clint Eastwood. Do you feel lucky, punk? Oh man. Anyway. Yeah. So anyway, sorry. 5 minutes of extra video you didn't need. I'll get back into the routine and such.